Okay, I'm going to try to just create this video to show you how to do another problem in case you look at this answer sheet and you forget how to do what. However, I'm going to be using the laser to sort of talk a little bit about the different parts A through F, and I hope that it helps. I'll try to create another video to help you with the first part of review for the test, but you know, we're running short on time, so I'll try my best. But in any case, let's go over, let's say, question 4. So question 4 part A asks, find the x-intercepts. And again, to find the x-intercepts, you are just setting the factors equal to 0, okay, and solving for x. Now, remember that the 3 on top doesn't have anything to do with solving for the x-intercepts. It only tells you the multiplicity for the x-intercept. So keep that in mind, all right? Part B here is finding the y-intercept. So make sure that to find the y-intercept, all you have to do is plug in 0. So plug in 0 here, and compute the problem. And then again, you don't necessarily need to get to the end, especially if the number is like pretty big, right? Because you're not going to have a calculator. So just leaving it as 8 times 1 should be just fine. So again, I'm pretty sure these are correct, but if any of these come out to be wrong, please feel free to shoot me an email. Maybe I overlooked something, and I'll fix it. The next part is part C, which is determine the behavior, the function that represents the end behavior, okay? So just a quick pause here. Someone asked me if you're going to need to remember all parts of what you need to do to solve this entire problem. And no, you're going to be given the A through F, you know, so it's going to tell you what you need to find. C is find a function that determines the end behavior. First and foremost, I don't want anybody to get this wrong, so make sure when it says find a function that determines the end behavior, that means your answer should be in the form of f of x equals something, right? That is a function that represents the end behavior. And so there are two things that you should look for when determining the end behavior of a function, and that is, hopefully you know, degree and leading coefficient. So in this case, you know, you always have to be careful. Don't just try to rush and do the shortcut, right? But in any case, right here, if you work it all out, this is really just x minus 8 times x plus 1 3 times, right? Because that's its multiplicity. So you can ask yourself, how many x's are there? If you count them, x 1, 2, 3, 4, and that tells you the degree. The degree is 4 because that's how many x's there are. But let me just quickly move from here and go to, is it going to be on something like this? Let me see. Let me go to something like this on the bottom right here. Don't get carried away and say, oh, this bottom one has, you know, 2 x's here and 3 x's here, and that's third degree. No, that's not. When it's in this form, which is standard form, you're looking for the x with the highest exponent. So the degree for this one would be 2, right? However, when it's in factored form, that is when you're able to just count the number of x's like I just showed you, right? When it's in expanded form. Worst case scenarios, you're going to have to, like, we did this in class, I believe, is do something like this, right? Plus 1. And then you go, oh, x times x is x squared. So if it was just 2 monomials like this or 2 binomials multiplying each other, then you would have to do something like that. But anyways, when it's in factored form, know that you can count the number of x's. So the degree is 4. Now, if you worked it all out, you'll realize that this part right here tells you this is the leading coefficient and it's -1. So at the end of the day, the function that represents this number 4 is -x to the 4th power, okay? Once again, for D, it asks, what is the behavior of the function near the x-intercepts? You have to reference the x-intercepts that you got. You already got those in part A. Now you have to remember the degree, you know? So in this particular case, you know, we have written down f crosses, right? But doesn't touch at both x equals 8 and -1, because what is the multiplicity of each of these? The intercept 8 has a multiplicity of 1 because look at its exponent right here. It's just 1. The multiplicity of 1 is 3 because if you look at its exponent, it's 3. Now, remember that crossing and touching is all about odd or even. Because both of these are odd, they both touch. So you could put them down as one whole answer. But at the end of the day, you have to express how you got that, right? So just say because the roots or the zeros or the x-intercepts 8 and 1 have odd multiplicity. That's you writing down what you just wrote down. That says like multiplication, but it's multiplicity. And that's really the reason why you wrote this part down, right? So just keep that in mind. Turning points. Turning points is easy money if you don't forget how to find the turning points. Remember that turning points is degree, and our degree was 4 minus 1 equals 3 turning points. Almost bit my lip on that one. 3 turning points, right? Once again, if you notice, this part D, this part E, they rely on the previous information, the degree that you sort of determined here, and the x-intercepts, right? So it's there, right? This one doesn't say F, but this is part F here, which is sketch a graph. So a few people were telling me how do I know what this shape of the graph is gonna look like? Is it gonna look like this somehow, or is it gonna look like this, right? This all goes back to is it gonna look like this? It all goes back to parent functions, right? That's why I need you to know all the parent functions. I need you to know that one. Whoa, that's a weird S, but that one, right? That one, and the new ones that we covered for the rationals, right? We need to know these right here. That one, that's like this. Sorry, I'm trying to make this so it doesn't erase. That one, and then also don't forget these right here that are like little arrows like that, right? So, again, that talks about 1 over x, -1 over x, -1 over x squared, and 1 over x squared. You need to know those functions, those 4 functions, please. Okay, so first of all, when you graph this, make sure that you graph the roots, the zeros, right? -1 and 8. You had already computed those earlier, so that's how we wrote these here. And in this particular case, we can graph the y-intercept, which is up here. However, let's say your y-intercept was all the way up here, then just extend the graph. If this was that case on this one, just do something like that, right? Whoops, it's supposed to cross 8, right? Do something like that, and I will know what you're doing, right? It doesn't have to be perfect, but in any case, let's dissect how I drew this graph, right? Once I did this, I realized that it was this one. So I remember that to the 4th power, it's gonna be not a u, because u is -x squared, but because it's -x to the 4th, it's really like 1, 2, 3, 4, like that, like a W upside down. I don't think you'll have an x to the 4th on your test, but in case you do, I'll walk around and see how everybody's doing. But in any case, the way this works is I know it's a sad face because it's negative at the front, and I know that it's going to be something like a W because it's a 4th degree, right? So I start with the -1 and ask myself, okay, once I get here, what's the multiplicity? It's 3. So what it does is this. It goes to -1, then it tries to turn down because it has a degree of 2, but then it has a degree of 3. So then it goes back up all the way to 8, because remember, that's the y-intercept. And then it goes down to 8. And what's going to happen at 8? Well, if you look at 8, 8 has a multiplicity of 1. Therefore, it crosses, right? And that's why we wrote this part down here, that it crosses. Again, when it goes up to -1, it stays there. And it's going to go down because it's degree 2. But then, it's like a reader. It reads it. How many multiplicities does it have? Oh, it has one more because it has 3. All right, instead of shooting back down, I'm going to have to climb back up all the way to 8, and 8 has a multiplicity of 1, so it's cross, not touch. So then that's how I get that, right? So just be careful, you know, I really want you to try to memorize as many of these parent functions as possible. That'll really help you get this one down. But if you want me to do another specific problem, let me know. And I will try to do it today ASAP, okay? Good luck.